Gravity, the reason rain pours downwards and apples fall down trees. But it's also the reason for one of the most tragic ways you can die in a video game.
To what?
Well, it's not all about things falling down. It's because of gravity that clocks in Jupiter tick slower than clocks on Earth. That there are regions in space where nothing, not even light, can escape it. And that some things aren't where we think they are. From thinking of gravity as something that makes objects on Earth fall down, how did we get to the really advanced ideas about gravity that we have today? Hey yo, it's Science Beam, and I'm here to teach you some Science Beam. Well, the first thing we think of when we hear the word gravity is that it's something that keeps us from flying out of Earth. Similar to one of the earliest definitions of gravity. So Aristotle was a student of Plato, and both these guys wrote a lot of their observations down. But Aristotle was a bit more organized. His goal was to share what he knew. So this is something that's brought up a lot when you read about the history of gravity. Aristotle divided matter into earth, water, air, and fire. He said that things moved because they want to go back to their proper places. Obviously, this sentence doesn't apply to people, because people belong everywhere on Earth. Anyways, Earth belonged at the very center of, well, Earth. Water would wrap around Earth, air would go on top of water, and fire on top of air. Then Galileo, around 2,000 years later, was like, nah, man, that's not it. That's not quite it. So Galileo read a lot on Archimedes. Unlike his colleagues who were reading more on Aristotle, he understood from Archimedes' law of buoyancy that less dense objects have a harder time going to the bottom of a container, for example. So if we replace water with, say, air, we should observe the same behavior, and less dense objects do take a longer time reaching the ground. Some more intrusive thoughts come in, and he thinks of removing that air. Everything should fall down at the same rate then. And this was how we started explaining the behavior of objects we can easily observe, things that are around us. What about everything else in the universe? See, another thing that Aristotle talked about was how the heavens are a separate realm, perfect and with their own rules. He was talking about outer space. And people believed this for a very long time until Galileo started pointing his telescope to the sky and saw craters on the moon. For some reason, 16th century people didn't think craters were perfect. For them, perfect was smooth, which is also a random as definition for perfect. And so they started questioning whether the heavens were actually separate from Earth. We'll get back to this later. In the meantime, people still kept recording things they saw in the sky, mostly for making calendars and navigating using the position of stars. To be fair, people were traveling on ships at this point in human history. During this time, Tycho Brahe was known for his accuracy in making astronomical records. He made a lot of observations on things like the motion of Mars or some dot he saw for a while and then disappeared, which later turned out to be a supernova. His observation of the supernova was important because at the time people thought everything in the sky was perfect and unchanging. Remember, they were already questioning the perfection of the heavens because of the craters on the moon. And this is a really lovely moment in human history whenever we question things, instead of accepting truths that sound comforting. But let's give some more emphasis on that data Tycho had on the motion of Mars, because this was the data that Kepler used later on to come up with his 3 laws of planetary motion after his mentor Tycho died. Now, how are those laws of planetary motion so important in the progress of understanding gravity? Some white dude later on called Isaac Newton wanted to know why Kepler's laws worked, and he thought about it a lot, eventually coming up with a theory of gravitation. So I'm not going to talk about Kepler's rules like I did 6 years ago. You can search these rules on your own, to be honest. This video is about the bigger picture, which is this. Kepler explained how planets move, but Newton defined what made these movements possible. So there is a force two objects experience due to their masses. The two bodies experience the same amount of force, but since they have different masses, for example the Sun and the Earth, they each experience different accelerations. Newton, as he supposedly watched an apple fall down, saw that this apple from this distance from the ground felt an acceleration due to gravity, a big enough acceleration to let us observe the movement, because even as the force experienced by the Earth and the apple are equal, the apple has such a small mass. Newton thought that this should be the same for all objects. And if we look a little bit higher than that tree where the apple came off, we can also wonder about the motion of things in the sky like the moon. Remember how I said people at the time of Tycho Brahe thought everything outside of the Earth was completely separate from us? Newton completely changed this. The motion of things falling on Earth is just the same kind of motion of whatever is going on in space. Huge things in space, like planets, just happen to be falling in some kind of style, in a circle-y, not really a circle, style. So Aristotle was wrong about this, and so was everybody until 1687, when Newton published his work describing gravity. So Newton talked about the effects of gravity on the movement of planets, of comets, but Einstein wanted to get deeper. He wanted to get deeper. This was actually the first episode in a series that I started for my channel a few years ago. We talked a lot about gravity, especially gravitational waves, and now you don't have to remember all of the concepts in those science videos. What I want you to leave with is the fact that the progress we have about understanding the world around us, may that be about gravity or light, this progress was possible because a lot of people kept asking why, kept asking how, kept asking for specificness and concreteness. This is really the point of these videos. So thanks for watching, I will see you next time. Check out some of these other videos if you haven't seen them yet.